For tens of thousands of years, most of humanity moved toward warmer lands. Only one migration went in the opposite direction. It ventured into a place where life itself nearly came to a halt, and that single decision gave rise to one of the most extraordinary stories in human history. About 1,000 years ago, while most civilizations around the world had never even known of the lands bordering the planet's northernmost edge, an extraordinary migration quietly unfolded amid sea ice and relentless snowstorms. These were simply families traveling with young children, sled dogs, a handful of boats covered in sealskin, and the entire body of survival knowledge their ancestors had accumulated over countless generations. They left northwestern Alaska and journeyed eastward, toward a horizon that appeared to be nothing but endless white. What is remarkable is that they succeeded. Between the 11th and 13th centuries, these communities expanded their range by more than 3,400 miles, from Alaska across the Canadian Arctic archipelago all the way to Greenland. This is considered one of the fastest territorial expansions ever documented in the archaeological history of the Arctic. Even more astonishing was the route they chose, the very edge of the sea ice, a place most people would regard as the boundary between life and death. These pioneers belonged to the Thule culture, the direct ancestors of most modern Inuit people. Their arrival marked the birth of an entirely new system of survival. While earlier Arctic communities had relied primarily on seals, caribou, and smaller animals, the Thule mastered the largest animal in the entire Arctic Ocean, the bowhead whale. But hunting such a colossal creature was the achievement of an entire civilization that knew how to combine technology with the power of community. Large umiaks carried groups of hunters. Small, agile kayaks closed in on the prey. Detachable harpoon heads connected to sealskin floats gradually exhausted the whale. Every member worked together with near-perfect coordination. That era also brought a rare opportunity. From about AD 950 to 1250, the North Atlantic experienced a relatively warmer climatic period, commonly known as the medieval warm period. For the Thule, it was as though nature had opened a new passageway before them. They did not fight the sea ice, they learned how to read it. Today, from Alaska to Nunavut, across northern Canada and into Greenland, archaeologists continue to uncover semi-subterranean houses, whale-hunting harpoon heads, walrus ivory tools, slate implements, and animal bones that all share the distinctive style of the Thule culture. More importantly, ancient DNA sequencing studies published in Science show that modern Inuit people trace the majority of their ancestry to the Thule, rather than to the Paleo-Inuit communities that had lived across the Arctic thousands of years earlier. Where did those earlier people go? What caused an entire civilization that had endured for so long to nearly vanish from history? And did the Thule ever encounter them? The story begins about 4,500 to 5,000 years ago, when the first groups belonging to what archaeologists call the Arctic small tool tradition, ASTT, emerged from the Bering Strait region and rapidly spread across Alaska, northern Canada, and eventually Greenland. Rather than crafting large axes or spears, they created remarkably small yet exceptionally sharp stone blades that could be fitted into bone or wooden handles, transforming them into a wide variety of tools. From this original tradition, a succession of cultures gradually emerged, including Sakak, Independence I, Independence II, Pre-Dorset, and finally, Dorset. You do not need to remember every name. What is far more important is that each of these communities represented a different human experiment in answering the same question. How do you survive in a world locked in ice and snow year-round? One of the discoveries that completely transformed our understanding came in 2010. From the permafrost of Greenland, scientists successfully extracted and decoded DNA from a lock of hair belonging to a Sakak man who had lived about 4,000 years ago. It was the first time the world had recovered nearly an entire genome from an ancient person in the Arctic. The results were astonishing. This man traced his ancestry to ancient populations from northeastern Siberia, yet his genetic profile was clearly distinct from that of modern Inuit people. Among all Paleo-Inuit cultures, the Dorset remain the most mysterious. They lived across the Arctic from about 500 BC until roughly the 13th to 15th centuries AD, leaving behind countless finely crafted carvings made from walrus, ivory, soapstone, and animal bone. In Inuit oral tradition, they are known as the Tuniet, people who were powerful, quiet, and rarely spoke to outsiders. What has drawn particular attention from scientists is how different Dorset technology was from that of the Thule who arrived later. They used Quillig stone lamps fueled by seal oil to provide heat and light throughout the long Arctic winters. Yet to this day, there is still no clear evidence that they developed a large-scale system for hunting whales. This is also where the mystery begins. Around the 13th century, the Arctic climate gradually became colder with the onset of the Little Ice Age. As sea ice changed, so did the migration routes of seals, walruses, and many other marine animals. At the same time, Thule communities, equipped with more advanced hunting techniques and more adaptable means of transportation, began expanding into many of these regions. For years, it was widely believed that the Thule had wiped out the Dorset. But modern archaeological and genetic research has found no convincing evidence of a large-scale war or any significant genetic mixing between the two populations. What is truly astonishing is that this story has been pieced together from thousands of bone fragments, stone tools, ancient DNA samples, isotope analyses of both human and animal bones, and climate reconstruction models spanning thousands of years. Perhaps even the Dorset themselves could never have imagined that. And their disappearance left behind a historical void, waiting for a new civilization to fill it. They did not simply create tools to survive. They built an entire technological system that functioned in harmony with the sea ice, the wind, the animals, and the Arctic winter. It was that system that enabled the Inuit to write the next chapter of history. One of the clearest examples is the kayak. Originally, it was created as an almost perfect hunting machine. Its frame was built from driftwood or whale bones, then completely covered with waterproofed sealskin. To seals or walruses, an approaching kayak was far more difficult to detect than a larger boat. If it happened to capsize in waters hovering around 32 degrees Fahrenheit, where the human body can quickly lose the ability to function, the paddler could perform the Eskimo role to right the kayak without ever leaving the cockpit. But one person could not hunt whales or transport an entire family in a kayak. That is why the Inuit developed the umiak, a large boat that many researchers have compared to the pickup truck of the Arctic. The kayak and the umiak did not compete with one another. They functioned like two interconnected parts of the same system, each serving a different purpose while perfectly complementing the other. If boats made it possible to reach the prey, then the harpoon was the invention that most clearly revealed the Inuits' mechanical ingenuity. Instead of fastening the harpoon head permanently to the shaft, they designed it to detach after penetrating the animal's body. The Inuit did not try to overpower nature. They allowed the prey's own movement to work in their favor. That same ingenuity can be found in even the smallest tools. The ulu knife, with its distinctive semicircular blade, was commonly used by women to cut meat, skin seals, prepare food, and sew clothing. Its curved shape distributed cutting force evenly across the blade, reducing strain on the wrist during long hours of work in freezing conditions. Another example is the snow goggles, carved from bone or wood, with nothing more than a narrow slit in front of the eyes. Without using glass lenses, simply by limiting the amount of light reaching the retina, the Inuit greatly reduced the risk of snow blindness caused by ultraviolet light reflecting off the ice. Perhaps the most misunderstood invention of all is the igloo. Popular culture often leads us to believe that the Inuit lived year-round in houses made of snow. In reality, igloos serve primarily as temporary shelters during winter hunting expeditions. The Inuit also designed the entrance lower than the living floor, creating a cold trap that kept dense cold air near the bottom while allowing warmth from human bodies, and the Quillic stone lamp, fueled by seal oil, to collect in the upper living area. Even when temperatures outside could fall below -40 degrees Fahrenheit, the inside of an igloo could still remain between about 32 degrees Fahrenheit and 60 degrees Fahrenheit. warm enough for people to rest and survive the night. That is why the Inuit were able to adapt to an environment that many civilizations before them could not overcome. Yet every one of those remarkable engineering achievements ultimately served a greater purpose: harnessing the Arctic's most valuable resource. It was the bowhead whale. Many people believe the Inuit survived primarily by hunting seals. That was true for some communities, but for many Thule groups across Alaska, northern Canada, and Greenland, it was the bowhead whale that became the foundation of their prosperity. An adult bowhead whale can grow between 50 and 60 feet long and weigh approximately 75 to 100 US tons. Every whale hunt was planned long before the first umiak ever left the shore. Experienced elders observed wind direction, ocean currents, and the movement of sea ice to predict when the whales would pass through. Skilled craftsmen inspected every binding on the umiak, every length of rawhide rope, and every harpoon head. Women prepared cold weather, clothing, food processing tools, and storage areas for preserving the harvest after the hunt. Even children took part by learning how to read the sea, recognize seabirds, and notice the subtle signs that whales were approaching. A successful hunt was the achievement of an entire community, not the triumph of just a handful of hunters. In many indigenous traditions, whales were treated with profound respect because people believed that a hunt could succeed only when humans maintained balance with nature. The value of a whale was not measured solely by its enormous supply of meat. What truly made the difference was that nearly every part of its body was put to use. The meat was shared among families and could be naturally preserved for months in the Arctic cold. The skin and the thick layer of blubber beneath it, known as muktuk, were not only a traditional food but also a valuable natural source of vitamin C, helping reduce the risk of scurvy in an environment where fresh fruits and vegetables were almost non-existent. The blubber was also rendered into oil to fuel Quillick stone lamps, providing light, heat, and cooking energy throughout the long winter. Massive ribs and jawbones became the framework for semi-subterranean homes in regions where trees were almost entirely absent. Tendons and connective tissue were twisted into cordage, while baleen plates were crafted into a wide variety of tools. However, in many other regions, seals were the primary source of food. Farther inland, Arctic caribou became the main source of meat and hides. Many communities depended on freshwater fish, marine fish, or walruses. It is this diversity that truly reflects the nature of the Inuit. They did not impose a single survival strategy everywhere they went. Instead, they continuously adapted to each local ecosystem. Another aspect that is often overlooked is how the harvest was divided. The distribution of meat, blubber, and other valuable parts followed community rules that had been passed down through generations. Elders, families facing hardship, and everyone who had taken part in the hunt all received their share. As a result, sharing was not merely a cultural value. It was a survival strategy that gave the entire community a better chance of enduring years of scarcity. But just as the Inuit were mastering the frozen seas through knowledge accumulated over centuries, another civilization was advancing toward Greenland from the opposite side of the Atlantic. By the end of the 10th century, Greenland had become one of the very few places on Earth where two civilizations that had developed almost entirely independently happened to encounter one another. From the east, Eric the Red led Viking settlers from Iceland to Greenland around AD 985, establishing two major settlements known as the Eastern Settlement and the Western Settlement. For centuries, this encounter was often told as a story of fierce battles. Some Norse legends referred to the native inhabitants as the Skraeling, a term used for the people of the Arctic. Meanwhile, Inuit oral traditions also preserved memories of strangers arriving aboard large wooden ships. This led many people to believe that the Vikings and the Inuit had fought a prolonged war. Researchers have uncovered iron nails, iron chain fragments, copper, and wooden artifacts of Norse origin at several Thule settlements in Greenland and on Ellesmere Island. The Vikings came to Greenland, determined to preserve the familiar way of life they had known in their homeland. They raised livestock, cut and stored hay for the winter, built homes in the Scandinavian style, and depended on ships crossing the Atlantic to bring iron, timber, and many essential goods from Norway. During the early decades, while the North Atlantic remained relatively warm throughout the period known as the medieval climate anomaly, this system continued to function. But eventually, nature changed course. Beginning in the 13th century, the climate gradually cooled, growing seasons became shorter, sea ice expanded, and ships from Europe found it increasingly difficult to reach Greenland. At the same time, the economic system that had sustained the Vikings for generations began to lose its foundation. Meanwhile, the Inuit experienced almost none of the same shock because they had built their entire society on flexibility. Another question that has fueled scientific debate for decades is whether the Vikings learned from the Inuit. To this day, the answer remains uncertain. There are some indications that the Norse used marine animal products obtained from the Inuit and may even have observed their hunting techniques. However, archaeology has uncovered no evidence that the Vikings widely adopted kayaks, umiaks, or seal hunting strategies on sea ice. By the middle of the 15th century, the Viking settlements in Greenland had disappeared one by one. The western settlement was abandoned first, and the eastern settlement also showed no signs of continued occupation after the early 1400s. For centuries, their fate remained one of history's great mysteries. Today, through isotope analysis of human bones, paleoclimate data, archaeology, and Norse historical records, most researchers conclude that their disappearance resulted from a combination of a colder climate, declining trade, changing resources, a shrinking population, and limited ability to adapt to a new environment. Most importantly, there is no reliable archaeological evidence that the Inuit destroyed or replaced the Vikings through large-scale warfare. This was a confrontation between two different strategies for survival. After seeing how the Inuit conquered the Arctic through technology, knowledge, and strong community organization, many people might think the secret to their survival has already been explained. Yet modern science has uncovered an even deeper layer. One of the most remarkable discoveries involves their traditional diet. For months at a time, the Inuit had virtually no access to leafy vegetables, fruit, or grains. Most of their energy came from fish, seals, walruses, and whales. Foods exceptionally rich in fat and protein. To many people today, such a diet could increase the risk of metabolic disorders if maintained over long periods. So why were the Inuit able to thrive? In 2015, a study published in Science analyzed the genomes of the Greenland Inuit and identified variations in the FADS1, FADS2, and FADS3 gene cluster, which plays a key role in fatty acid metabolism. This provides compelling evidence that living in the same environment over long periods can alter the frequency of genetic variants within a population. Evolution does not create perfect humans. It creates bodies that are suited to their particular environments. The Arctic climate also helped shape the Inuit body. Many traditional Inuit communities tend to have shorter, sturdier builds with relatively shorter limbs, which help reduce heat loss. Some studies have also documented differences in peripheral blood flow regulation and heat production during exposure to extreme cold. However, scientists emphasize that these are only statistical trends. Perhaps the most remarkable lesson of the Inuit story is that it has changed the way we think about evolution itself. Many people assume that evolution belongs only to the distant past. Yet under environmental pressures that are strong enough and persistent enough, it continues to unfold even within the recent history of our own species. The Inuit are living proof of that. The greatest legacy they passed on to future generations lies not only in their genes, but also in their memory, their language, and thousands of years of experience observing the natural world. If the previous chapter showed how thousands of years of evolution left their mark on the bodies of the Inuit, this one reveals an even more astonishing truth. What enabled them to survive for so long was found not only in their DNA, but also in their memory. That is why many anthropologists regard traditional Inuit knowledge as one of the world's greatest living libraries, where knowledge is preserved within people rather than on paper. The Inuit call this body of knowledge Inuit Kajimajatuchangit, IQ, meaning that which the Inuit have long known. It is not simply hunting experience, but an understanding of nature, community, and living in harmony with the environment. Long before satellites or GPS existed, Inuit hunters could judge the safety of sea ice by its color, the sounds echoing beneath their feet, and the patterns of wind-shaped snow on its surface. To an outsider, it was nothing more than endless white. To the Inuit, it was an entire map filled with information. Do you think you could tell which ice was strong enough to walk on without using a single piece of equipment? Their ability to navigate has also amazed researchers. Even during a whiteout, when the sky and the ground blend into a single sheet of white, the Inuit could still determine direction by reading sastrugi snow formations, the positions of the stars, the flight paths of seabirds, and the inuksut, stone markers used to identify travel routes, hunting grounds, or dangerous areas. In many ways, it was the Arctic's own GPS system, long before humanity ever placed satellites into orbit. This entire body of knowledge was passed down through real-life journeys and oral storytelling. The legend of the sea goddess Sedna was not merely a spiritual belief, but also taught people to respect animals and avoid over-harvesting them. Stories about the Angakuk likewise passed on the values of sharing and responsibility toward the community. Every story became a lesson in survival preserved within the collective memory. What is truly remarkable is that modern science is now learning from this living library. Indigenous knowledge does not stand in opposition to science. Instead, it has become a vital piece of the puzzle that helps science better understand what is happening. Perhaps the Inuits' greatest legacy is not the kayak or the igloo, but the ability to listen to and understand the language of nature. But what happens when that very book is being rewritten? As sea ice melts earlier, animal migration routes shift, and patterns that remain stable for thousands of years gradually disappear. Will that living library still be enough to guide the way? The greatest paradox of the 21st century is that their most formidable enemy is no longer the cold, but the disappearance of the cold itself. For the first time in modern history, the Arctic is changing so rapidly that knowledge accumulated over hundreds of years is sometimes no longer enough to predict what tomorrow will bring. According to reports from the IPCC, NOAA, and the Arctic Report Card, the Arctic is warming approximately 3 to 4 times faster than the global average due to a phenomenon known as Arctic amplification. As sea ice melts, the darker ocean absorbs more heat instead of reflecting sunlight, causing temperatures to rise even further and accelerating the melting of even more ice. It is a self-reinforcing feedback loop unfolding across millions of square miles of the Arctic Ocean. For the Inuit, climate change does not appear as lines on a graph. It unfolds beneath their feet. Ice routes that once remained reliable throughout the winter now form later, become thinner, and melt earlier. In some places, dangerous cracks can appear overnight. Imagine if the road you traveled every day kept changing without following any predictable pattern. That is now the reality for many Inuit hunters. Those changes quickly spread throughout the entire ecosystem. Seals, polar bears, bowhead whales, walruses, and many fish species all shift their ranges as sea ice disappears. Hunting trips that once lasted only a few hours can now take an entire day while consuming far more fuel. For communities where imported food is extremely expensive, this affects not only their culture but also their food security. Meanwhile, permafrost, the permanently frozen ground, is also thawing, causing homes to sink, roads to crack, and coastal erosion to intensify. Some communities, including Shishmaref and Nutok in Alaska, have already begun planning relocation. But losing a village is not simply about losing homes. It also means risking the loss of memories tied to the land of their ancestors. Even so, the story is not only one of loss. Today, the Inuit have become essential partners in climate science. Researchers have realized that while satellites can measure the extent of sea ice, they cannot replace the daily observations of indigenous communities. The Siku platform, developed with the participation of Inuit communities, allows hunters to share data on sea, ice, weather, and wildlife in near real time. By combining indigenous knowledge with satellite imagery and climate models, scientists gain a far more complete picture of the changes unfolding across the Arctic. Perhaps this is the most beautiful paradox of our time. The more advanced technology becomes, the more humanity realizes that the Arctic cannot be fully understood without the voices of the people who have lived with this land for thousands of years. And when we look back across the entire journey of the Inuit, from their migration across Beringia, to their hunts on the frozen sea, to the imprint of evolution in their DNA, and the vast body of knowledge preserved through memory, we realize that the greatest miracle is not that they survived the cold, but that they always knew how to adapt as the world changed. But will that ability be enough to carry them through the fastest transformation in modern history? We often think of the Arctic as a silent, endless expanse of white. But to the Inuit, every sheet of ice is a map, every wind is a guide, and every footprint in the snow preserves the memory of their ancestors. The greatest wonder of their history is not that they survived the cold, but that they learned how to transform a land that seemed impossible to inhabit into their home for thousands of years. No one believed that an entirely different kind of human could still be hidden beneath the ground of South Africa. Then, in 2013, everything changed. By pure chance, researchers uncovered a handful of bones belonging to humans no one had ever known existed. And the most unsettling part was this: the story of human evolution may never have been as simple as we once believed. This is the story of Homo naledi. It all began as a routine expedition when cave explorers Rick Hunter and Stephen Tucker surveyed the Rising Star cave system in South Africa's Cradle of Humankind, a UNESCO World Heritage Site renowned for preserving countless fossils of early human ancestors. Inside a chamber that had received almost no scientific attention, they came across several fragments of bone. At first glance, they appeared no different from the many animal fossils that had already been discovered throughout the region. But when the photographs were sent to paleoanthropologist Lee Berger at the University of the Witwatersrand, he immediately realized they could represent something entirely different. The greatest challenge, however, was finding a way to reach them. To access the fossil chamber, the research team had to navigate a vast underground maze stretching hundreds of feet. The journey began with a steep rock ridge known as Dragon's Back, followed by the infamous passage called Superman's Crawl. Yet neither of these proved to be the final obstacle. Ahead lay a nearly vertical rock fissure whose narrowest point measured only about 7 to 8 inches across, roughly the width of a sheet of printer paper laid on its side. A single deep breath or carrying too much equipment could leave someone trapped inside the mountain. After squeezing through the crack, the archaeologists still had to descend nearly 40 feet before reaching the Dinaledi chamber, a cavern that had remained in complete darkness for hundreds of thousands of years.
The man is hopelessly insane.
The challenge forced Lee Berger to search for archaeologists who possessed not only scientific expertise, but also climbing skills, caving experience, and bodies small enough to fit through a gap only a few inches wide. In the end, 6 female scientists from several countries were selected. They soon became known around the world as the underground astronauts. Then, as the beams from their headlamps swept across the chamber, they revealed a sight that left the entire team almost speechless. Beneath the layers of sediment lay not just a handful of scattered bones, but thousands of fossils spread across the cave floor. After years of excavation, researchers recovered more than 2,000 fossil specimens representing at least 28 individuals of Homo naledi. What made the collection extraordinary was that it preserved nearly the entire life cycle of a population. From infants and young children to adolescents, fully grown adults, and the elderly. In paleoanthropology, discovering even a single nearly complete skull is considered exceptionally rare. Yet at Dinaledi, scientists were able to study an entire community spanning every stage of life, allowing them to reconstruct body structure, patterns of growth, and differences between individuals with a level of precision that very few archaeological sites anywhere in the world can provide. To this day, it remains one of the richest collections of ancient human fossils ever discovered in Africa. The more scientists studied the evidence, the more they realized that the simplest explanation seemed to be the hardest one to accept. The first hypothesis was that the chamber was nothing more than a natural trap. Even today, sinkholes and deep caves exist where animals accidentally fall in and die because they cannot escape. Over time, the remains of many individuals accumulate, creating what scientists call fossil graveyards. But when geologists analyzed the structure of the Rising Star cave system, they found that more than 99% of the fossils in the Dinaledi chamber belong to a single species, Homo naledi. Homo naledi may have deliberately placed their dead inside the cave. This hypothesis was first proposed by Lee Berger and his colleagues in their earliest publications, and it remains the most controversial aspect of the discovery to this day. They may simply have carried the deceased to a separate location rather than leaving the bodies where they lived. What makes this even more fascinating is that the scientific community itself remains highly cautious about this hypothesis. Many experts argue that the current evidence is still insufficient to conclude that Homo naledi intentionally disposed of their dead. And it is precisely that uncertainty that has made Homo naledi one of the most compelling mysteries in the study of human evolution. But if Homo naledi truly ventured deep into the cave system time and again, they would have had to travel hundreds of feet through passages completely devoid of natural light. So what allowed them to find their way? Had they learned to control fire, or is this simply another coincidence that we have yet to fully understand? That very question opens the most controversial chapter in the entire story of Homo naledi, where traces of fire, engravings on cave walls, and mysterious structures hidden deep within the cavern begin to challenge every limit we have ever placed on a small-brained human species. First came the question of fire. It was far more than a source of warmth or a way to cook food. Inside a cave system like Rising Star, fire would have been almost essential for seeing the way forward. Just a few steps beyond the entrance, all natural light disappears. Berger and his colleagues argue that fragments of charcoal, soot deposits on certain rock surfaces, and areas showing evidence of past heating inside the cave may indicate that Homo naledi used fire for illumination. To date, however, no direct evidence has shown that Homo naledi knew how to make fire in the way Homo sapiens later did. Even whether they used fire regularly, or only under certain circumstances, remains unresolved. But fire was not the most astonishing discovery. In several areas of the Rising Star cave system, the research team also reported geometric engravings carved into the dolomite walls. These include intersecting straight lines, X-shaped figures, square-like patterns, and repeating motifs. According to Berger, the markings bear the characteristics of repeated cuts made by a sharp object rather than random fractures produced by geological processes. If that interpretation is correct, Homo naledi may have engaged in a form of symbolic behavior more than 240,000 to 330,000 years ago. This is where the debate becomes most intense. Many archaeologists and geologists argue that before describing the engravings as art or symbols, researchers must first demonstrate that the markings are truly the same age as Homo naledi, and completely rule out the possibility that they were created in modern times. The same controversy surrounds the hypothesis involving shallow pits and stone structures that Berger's team suggests may have been connected to the handling of the dead. Critics point out that these features could also have formed through natural geological processes. That does not necessarily mean Berger is wrong. It reflects the way science works. Throughout the history of archaeology, many discoveries that initially captured worldwide attention were later disproven, while other hypotheses first met with skepticism eventually became the foundation of modern science. And amid all these debates, researchers needed only to examine the skeleton of Homo naledi itself to realize that nearly every part of its body seemed to tell a different story. Its skull resembled that of very ancient ancestors, yet its feet looked remarkably similar to those of modern humans. Could it be that Homo naledi challenges not only our understanding of behavior, but also the very way we understand the evolution of the human body itself? Normally, experts can examine a fossil skeleton and determine with remarkable accuracy where it belongs on the evolutionary tree. But with Homo naledi, that rule almost completely breaks down. For this reason, Homo naledi is considered one of the clearest examples of mosaic evolution, a process in which different parts of the body do not evolve at the same time, but instead change independently under different selective pressures. The first impression comes from the head. The skull of Homo naledi is relatively low, with a sloping forehead and a face that still retains many primitive features. Its brain measured only about 28 to 37 cubic inches, less than half the modern human average of approximately 79 to 85 cubic inches. Judging by the skull alone, many paleoanthropologists would associate it with Homo habilis, or other very early members of the genus Homo. The irony is that we now know Homo naledi lived only about 335,000 to 236,000 years ago. At roughly the same time, the first Homo sapiens appeared in Africa. That shows that a primitive appearance does not necessarily mean a species lived in a much earlier age. But once we look at the lower body, the picture changes almost completely. The legs of Homo naledi were significantly longer than those of Australopithecus, while the feet were built much like those of modern humans. The big toe was aligned with the other toes rather than splaying outward as it does in the great apes. The arches of the feet were also well developed, helping absorb impact while walking and conserve energy over long distances. These are essential adaptations for a species that spent most of its time walking upright on the ground. This suggests that Homo naledi was exceptionally well adapted to life on the ground, even while retaining many ancient features in other parts of its body. Even so, they had not completely abandoned the world of the trees. The shoulders of Homo naledi remained relatively high. The shoulder joints faced upward, and the rib cage was conical in shape, traits commonly seen in climbing primates. Most striking of all, their finger bones were noticeably curved. This was not a random feature, but the result of long-term adaptation to regularly gripping, pulling, and climbing tree trunks or rock faces. When confronted by predators or searching for a safe refuge, climbing remained a major advantage. Perhaps the most surprising feature of all was the hand. On one hand, the curved fingers reveal an adaptation for climbing. On the other, the thumb was relatively long and robust, while the wrist shared many similarities with those of Homo sapiens and Neanderthals. These are the very features that make the precision grip possible. The ability to manipulate small objects and craft tools with remarkable control. The pelvis tells yet another story. It was relatively broad and retained many primitive characteristics, resembling Australopithecus more than later members of the genus Homo. Meanwhile, the average Homo naledi stood only about 4 feet 9 inches tall and weighed roughly 88 to 121 pounds, creating a body that was small, compact, and well-proportioned. No single body part could truly be described as either the most advanced or the most primitive. Homo naledi has fundamentally changed the way scientists think about evolution. But if the body of Homo naledi is a mosaic assembled from different stages of evolution, could its brain have worked according to the very same principle? Imagine a morning in the cradle of humankind in South Africa, about 300,000 years ago. For a Homo naledi individual standing only about 4 feet 9 inches tall and weighing an average of around 88 pounds, confronting an apex predator head-on would have been almost unthinkable. They lacked the speed of an antelope, the claws of a leopard, and the massive strength of a bear. So what allowed them to survive for tens of thousands of years in such a dangerous environment? The answer may lie in a combination of traits that have been shaped by natural selection over time. Their legs, built much like those of modern humans, allowed them to walk long distances efficiently, conserving energy as they traveled between seasonal food sources. Meanwhile, their shoulders and curved fingers, features that might seem outdated, became invaluable when they needed to climb trees or low rock faces to escape danger. The diet of Homo naledi also reflects that flexible survival strategy. They may have relied on wild fruits, seeds, tubers, insects, small animals, and even meat scavenged from carcasses whenever the opportunity arose. The fossils found at Rising Star represent every stage of life, from infants and young children to adults and the elderly. Children, with brains that were still developing, would have needed years to learn how to find food, recognize danger, and move safely through a landscape filled with predators. A mother on her own would have struggled to carry a young child, gather food, and remain constantly alert for leopards or hyenas. For this reason, many anthropologists believe that among ancient human species, caring for the young was most likely the responsibility of the entire group, rather than just the parents. Female Homo naledi were likely not limited to raising children. Standing an average of about 4 feet 9 inches tall and possessing compact bodies, they most likely took an active role in gathering tubers, fruits, seeds, insects, and other dependable food sources available throughout the year. In many modern hunter-gatherer societies, it is gathered plant foods, not meat from hunting, that provide most of the daily calories, while meat serves only as an occasional supplement. Perhaps the greatest strength of Homo naledi did not lie in muscle or brain size, but in their ability to sustain life together in the challenging landscapes of Africa. Yet nature was not their only rival. While Homo naledi was still adapting to a changing climate, an even greater transformation was unfolding across the African continent. For the first time in history, multiple human species may have shared the same land, hunted in the same landscapes, searched for the same water sources, and perhaps even seen one another. Did Homo naledi ever come face to face with our own direct ancestors? And if they did, what happened between those two human species? After millions of years of evolution, we tend to picture human history as a single line of figures standing one behind another. One species disappears, the next emerges, and eventually Homo sapiens is left standing alone. But Homo naledi has forced that familiar picture to change. When the fossils from the Rising Star Cave system were dated to roughly 335,000 to 236,000 years ago, scientists realized that at the very moment the first Homo sapiens were appearing in Africa, Earth was still home to several different human species. Each branch represented a different solution to the same challenge of survival. And Homo naledi was just one of nature's many remarkable evolutionary experiments. If we could travel back about 300,000 years, the world before us would look very different from what we imagine today. In southern Africa, Homo naledi would still be living among the familiar limestone landscapes and open grasslands. Far to the north, fossils from Jebel Irhoud in Morocco show that early Homo sapiens had already appeared by about 315,000 years ago, displaying many features of modern humans while still retaining several primitive traits. Meanwhile, in Europe and Western Asia, the ancestral populations of the Neanderthals were continuing to evolve as they adapted to an increasingly colder climate. Even farther east, in Asia, another mysterious human lineage that we now call the Denisovans was also alive, although most of what we know about them comes from ancient DNA and only a handful of fossils. Even more intriguing, many Middle Pleistocene fossils discovered in Africa still cannot be confidently assigned to any known human species, suggesting that the human evolutionary tree may contain many branches that science has yet to uncover. That means that, for a brief period in evolutionary history, Earth was home to multiple versions of humanity living at the same time. But does that mean they never encountered one another? The climate of the Middle Pleistocene changed constantly. The climate of the Middle Pleistocene changed constantly. A prolonged drought could have forced different human groups to gather around the same water source. The emergence of a new grassland might also have drawn populations that had once been separated into the same region. Imagine a morning 300,000 years ago. A small group of Homo naledi approaches a lake in search of water and food. From the opposite shore, a group of early Homo sapiens is doing exactly the same. How would they have reacted upon seeing another human species for the first time? Would they have watched each other from a distance in curiosity? Quietly avoided one another? Or competed over the same precious resources? Archaeology still cannot answer those questions. Yet the very possibility that such encounters may have taken place makes the story of humanity far more vivid. Elsewhere in the world, we know that different human species truly did meet. Modern DNA analyses show that most people living outside Africa today still carry about 1 to 2% Neanderthal DNA, while many people in Melanesia, Papua New Guinea, and parts of Asia also carry Denisovan DNA. That proves these human species did more than simply see one another. They also had children together. But what about Homo naledi? This remains one of the greatest mysteries of all. The hot, humid climate of southern Africa causes ancient DNA to break down rapidly, and so far scientists have been unable to recover the genome of Homo naledi. Without DNA, we still cannot determine whether they ever exchanged genes with Homo sapiens or remained entirely separate. Another hypothesis attracting considerable attention is ecological competition. In nature, two species can influence one another simply by relying on the same food sources or occupying the same habitat. Perhaps the most extraordinary legacy of Homo naledi is not that they eventually disappeared, but that they completely transformed the way we understand human history. Homo naledi is more than an unusual human species discovered inside a cave in South Africa. They are a reminder that the story of evolution has always been far more complex than we once imagined. After everything Homo naledi has revealed, the most astonishing discovery is not the sheer number of fossils or their age, but the fact that this small human species has forced the entire field of paleoanthropology to reconsider one of its most enduring beliefs. For more than a century, human evolution was often illustrated as a ladder ascending upward, with each step representing a species more advanced than the one before it. Larger brains, more sophisticated tools, and ultimately Homo sapiens standing at the top. But modern science has shown that nature has never followed such a straight path. And Homo naledi stands as one of the strongest pieces of evidence for that reality. What puzzles scientists is not that Homo naledi was either too modern or too primitive, but that it was both at once. They possessed brains measuring only about 28 to 37 cubic inches, dramatically smaller than the average Homo sapiens brain of roughly 82 cubic inches. Yet their bodies displayed many of the traits of highly efficient long-distance walkers. Their hands were dexterous enough to perform precise movements, and they lived between approximately 335,000 and 236,000 years ago, precisely when the first Homo sapiens had already appeared in Africa. That combination alone is enough to overturn the idea that modern traits must always emerge together in one fixed sequence. The concept that paleoanthropologists now use to explain this phenomenon is known as mosaic evolution. Different parts of the body can evolve at different rates if doing so provides a survival advantage. Homo naledi has also changed the way we evaluate intelligence and adaptability. For many years, brain size was often regarded as the single most important measure. Yet, as we have seen, size is only one part of the story. What matters even more is how biological traits work together to create a complete survival strategy. Another profound change brought about by Homo naledi is the way scientists think about the gaps in the fossil record. Before 2013, almost no one knew this human species had ever existed. Is Homo naledi truly a unique exception, or simply the first of many human species we have yet to discover? The history of science has repeatedly shown that every major discovery tends not to end a debate, but to open dozens of new questions. We still have no DNA from this species because Africa's hot and humid climate makes genetic material extremely difficult to preserve. The hypotheses that they regularly used fire, created cave engravings, or engaged in symbolic behavior are still being tested and have not yet reached broad scientific consensus. Perhaps the greatest lesson Homo naledi leaves behind is not whether they were our ancestors, but how they changed the very questions we ask about our origins. The history of the genus Homo is more like a sprawling bush with countless branches diverging, evolving side by side, and many of them quietly disappearing. Homo sapiens was not a predetermined destination from the beginning, but simply the branch that survived through countless changes in climate, environment, and evolution. And that may be the greatest legacy of Homo naledi. They did not change history by building civilizations or leaving behind cities of stone. They changed history by forcing modern humans to abandon an overly simple story about their own origins. Yet even after all these discoveries, one final mystery remains. What truly happened to Homo naledi? Why did a human species that survived for hundreds of thousands of years disappear while leaving behind so few traces? And was that disappearance truly the end, or merely a missing chapter in the evolutionary story that we are still writing? For more than 300,000 years, dozens of Homo naledi individuals lay silently in the darkness, leaving behind no cities, no written language, and no monuments. Perhaps the most astonishing fact is not that Homo naledi once existed, but that a single cave system in South Africa was enough to force scientists to rewrite entire chapters of the story of human origins. And if Rising Star was able to guard that secret for hundreds of thousands of years, then it is entirely possible that beneath other layers of rock across Africa, there are still unknown human species waiting to be discovered, waiting for the next breakthrough that could once again transform everything we think we know about the history of our own kind. Some names now exist only in the pages of history books. They vanished from the Earth nearly 40,000 years ago, but they never truly left humanity. Around 1 to 2% of the DNA carried by many modern people outside Africa still bears their genetic legacy. And with every new archaeological discovery, long-held beliefs about the Neanderthals continue to be overturned. This is the journey to uncover everything modern science truly knows about the Neanderthals. Nearly 800,000 years ago, the ancestors of modern humans, Neanderthals, and Denisovans had not yet diverged into separate branches. For centuries, human evolution was often imagined as a ladder, with Homo sapiens standing at the very top. But archaeology, fossil discoveries, and ancient DNA have revealed the opposite. Evolution did not follow a straight path. It unfolded more like a branching tree, with multiple lineages growing side by side. Neanderthals were not our direct ancestors. They were a human lineage that evolved alongside Homo sapiens for hundreds of thousands of years. According to most of the evidence available today, the common ancestor of Homo sapiens, Neanderthals, and Denisovans was most likely Homo heidelbergensis, or a population very closely related to that species. Around 700,000 to 600,000 years ago, part of this population left Africa, spreading into Western Asia and eventually Europe. It was there that nature began shaping two very different evolutionary paths. While the populations that remained in Africa continued adapting to a warm climate with abundant food, those living in Europe faced prolonged ice age cycles, an unstable climate, and increasing geographic isolation. After hundreds of thousands of years, they gradually evolved into Neanderthals. Meanwhile, in Africa, another branch ultimately developed into Homo sapiens around 300,000 years ago. For nearly 400,000 years, Neanderthals dominated much of Europe and Western Asia, surviving multiple ice age cycles while hunting mammoths, woolly rhinoceroses, and wild cattle across vast, frozen grasslands. During that same span of time, Homo sapiens continued to develop primarily in Africa. Two human lineages shared the earth, yet they were almost entirely unaware of each other's existence. If the history of civilization spans only about 5,000 years, then the period during which they evolved separately was more than 60 times longer. That distinction also gave rise to a debate that lasted for decades. Were Neanderthals a separate species or merely a subspecies of modern humans? The answer became much clearer in 2010 when scientists at the Max Planck Institute successfully sequenced the Neanderthal genome. The results revealed that most modern people outside Africa carry about 1 to 2% Neanderthal DNA, evidence that the two groups encountered one another and produced offspring together roughly 50,000 to 60,000 years ago. That same year, a tiny bone fragment discovered in Denisova Cave in Siberia revealed the existence of an entirely new human lineage, the Denisovans, showing that the story of humanity was once far richer than we had ever imagined. Perhaps the most astonishing fact is not how different Neanderthals were from us, but how remarkably successful they became. They were not a failed evolutionary experiment. They were nature's answer to a frozen world. But how did that environment reshape their bodies? Why did they develop such large noses, massive rib cages, powerful muscles, and brains that were even larger than those of modern humans? Imagine living in Ice Age Europe, where temperatures remain below freezing for months at a time. Cold winds sweep across grasslands stretching for hundreds of miles. Trees are sparse, and food supplies are always uncertain. There are no permanent shelters, no modern clothing, and no reliable source of energy. Under those conditions, simply maintaining body heat is already a challenge. This was the world that shaped the Neanderthals. Fossil evidence shows that adult Neanderthal men were usually about 5 feet 5 inches tall, while women were around 5 feet. They were not tall, but their bodies were exceptionally sturdy, with broad shoulders, thick bones, and highly developed muscles. The muscle attachment points on their bones indicate that they regularly performed activities requiring tremendous strength. This is consistent with archaeological evidence showing that Neanderthals hunted enormous animals with spears at close range. Their short, stocky bodies and relatively short limbs were not accidental either. Two well-known biological principles, Bergmann's rule and Allen's rule, suggest that animals living in cold regions tend to have broader bodies and shorter limbs to reduce heat loss. Neanderthals did as well. Their bodies function like a natural heat retention system, helping conserve energy in a frozen environment. Another striking feature was their large nose, and studies using CT scans and airflow simulations suggest that the Neanderthal nasal cavity may have helped warm and humidify cold air before it entered the lungs, while also meeting the oxygen demands of a muscular body with high energy consumption. Their brains have also surprised many people. The average Neanderthal brain volume was approximately 1,450 to 1,600 cubic centimeter, larger than the modern human average of 1,300 to 1,400 cubic centimeter. What matters is how the brain was organized, and some studies suggest that Neanderthals devoted more neural resources to controlling their powerful bodies and processing visual information under the low light conditions of high latitudes. This suggests that evolution produced a brain best suited to their environment. Ancient DNA analysis shows that Neanderthals carried many gene variants associated with immunity, energy metabolism, and adaptation to cold climates. Today, many people outside Africa still carry segments of Neanderthal DNA that influence the immune system, circadian rhythms, metabolism, and the ability to adapt to the environment. In a sense, the biological solutions Neanderthals accumulated over hundreds of thousands of years still survive within our own bodies. However, fossils from different periods show that they also changed over time. Neanderthals who lived 350,000 years ago were not exactly the same as the final populations living in Europe around 40,000 years ago. Like Homo sapiens, they continued to evolve in response to an ever-changing environment. When we bring all these pieces together, we realize that their large noses, broad rib cages, short limbs, powerful muscles, and massive brains were not signs of a primitive human species. They were evolution's answer to one of the harshest environments that had ever existed. But if the Neanderthal body was shaped so perfectly for survival, just how extreme must the world that created them have been? We are about to enter Ice Age Europe, a world that not only shaped their bodies but also determined the fate of an entire human species. For nearly 400,000 years, Neanderthals had to adapt to an ever-shifting environment, where grasslands could become forests and then return to open steppe within only a few thousand years. During the coldest periods, enormous ice sheets covered much of northern Europe, while sea levels stood about 390 feet lower than they do today, exposing land that connected Britain to mainland Europe. When the climate warmed, the ice melted, the seas rose, and the landscape changed once again. Imagine that generations within your community had survived by hunting reindeer across vast grasslands. Then, within only a few centuries, that land became forest. The reindeer herds disappeared, and the knowledge accumulated over countless generations became almost useless. One of the most remarkable ecosystems of that time was the mammoth steppe. Contrary to what many people imagine, it was not a land buried beneath snow, but a vast expanse of cold, dry grasslands stretching from Western Europe across Siberia and all the way to Alaska, inhabited by enormous herds of woolly mammoths, woolly rhinoceroses, ancient bison, wild horses, and reindeer. For Neanderthals, it was a valuable source of food, but it was also a place where every hunt could become a battle for survival. A single charge from a bison weighing more than 2,000 pounds, or one mistake in front of a woolly rhinoceros weighing nearly 6,000 pounds, could be enough to kill a hunter. Yet something even more unpredictable is recorded in Greenland ice cores. Numerous Dansgaard-Oeschger events, during which temperatures in the northern hemisphere may have risen by approximately 15 to 30 degrees Fahrenheit, within only a few decades. Every generation of Neanderthals had to learn how to adapt to an environment different from the one experienced by the generation before it. At times, these changes became even more violent during Heinrich events. When enormous ice masses in North America broke apart and drifted into the North Atlantic, the influx of fresh water weakened the ocean current system, causing Europe to become colder and drier within a relatively short period. Grasslands contracted, vegetation declined, and animal herds were forced to migrate hundreds of miles in search of new food sources. Archaeological evidence shows that Neanderthals did not simply wait passively. They retreated into southern Europe when the climate became too extreme, then expanded northward again when conditions improved. That ability to adapt was the key that allowed them to survive through repeated ice age cycles. Beyond the climate, Neanderthals also had to share their environment with some of the most formidable predators of the time. Cave lions, cave hyenas, ancient wolves, and cave bears weighing more than 2,000 pounds all competed for the same food and shelter. Many archaeological caves contain evidence that humans and large predators occupied them at different times. This means that whenever Neanderthals entered a rocky cave to escape the snow and wind, they faced not only the cold, but also the question of whether the cave's true owner had already left, or was still inside. What is astonishing is that they did not merely survive, but mastered this environment for nearly 400,000 years. Today, many scientists no longer view Neanderthals as victims of the Ice Age. But if physical strength alone was not enough to help a human species survive for so long, what was the real key? How did they hunt enormous animals, create effective tools, and maintain their way of life in an environment that never stopped changing? Physical strength was certainly an advantage, but it cannot explain why a human species with a relatively small population survived across Europe and Western Asia for nearly 400,000 years. To endure hundreds of winters and repeated climate shifts, they needed more than muscle. They needed knowledge, the ability to plan, and most importantly, the ability to pass experience from one generation to the next. Archaeological discoveries made over the past several decades show that Neanderthals did not merely react to nature. They understood it and knew how to make use of it. One of the clearest pieces of evidence is the Levallois technique, the foundation of the Mousterian stone tool culture. To create a sharp stone blade, the toolmaker could not strike the stone at random, but had to visualize the final shape in advance, then remove each flake in the correct sequence. Their weapons were also far more complex than the image of a crude wooden club, and extensive archaeological evidence shows that Neanderthals attached stone points to wooden shafts using birch tar. This adhesive could only be produced by heating tree bark in a low-oxygen environment under controlled temperatures. Fire was also an essential technology. At many archaeological sites, such as Abric Romani in Spain and Paich de Lauzet in France, researchers have discovered multiple layers of hearths repeatedly used in the same areas. This shows that Neanderthals not only knew how to maintain fire, but also understood how to organize their living spaces. During long winters, a hearth provided more than warmth. It became the center of the entire community. What truly distinguished Neanderthals, however, was the way they hunted. At La Côte de Saint-Brelade on the island of Jersey, extensive evidence suggests that Neanderthals repeatedly hunted large animals at the same location over a long period of time. The Neanderthal diet was also far more varied than previously believed. Stable isotope analysis shows that they were hunters positioned near the top of the food chain. But studies of microfossils preserved in dental calculus also prove that they ate seeds, berries, mushrooms, tubers, and many other types of plants. This shows that Neanderthals did not depend on a single food source. When the environment changed, they changed with it. Each hunt not only met immediate needs, but also prepared them for the weeks ahead. But if they could plan, control fire, produce adhesives, and organize highly strategic hunts, could there also have been a far more complex inner world and capacity for thought behind those stone tools? For a long time, Neanderthals were often portrayed as strong but slow, capable of little more than instinctive reactions. Yet modern technologies such as CT scanning, microscopic wear analysis, material chemistry, and experimental archaeology are telling a completely different story. What astonishes scientists is not that Neanderthals used tools, but the way they thought in order to create them. One clear example is birch tar. To produce this adhesive, they had to heat tree bark in a low oxygen environment at a controlled temperature for several hours. This suggests that Neanderthals did not learn only through trial and error, but were also capable of remembering and passing technical procedures on to later generations. At many sites in France, Germany, and Poland, archaeologists have discovered flint transported from sources located more than 60 miles away from the places where Neanderthals lived. This shows that they knew exactly which types of stone were suitable for making tools and planned hunting expeditions or long-distance journeys in advance. At Abric, Romani in Spain, layers of ash, hearths, tool-making areas, and places where prey was processed were arranged separately across repeated periods of occupation. This suggests that they organized their living spaces in a systematic way. At Molodova in present-day Ukraine, archaeologists also discovered a circular structure made from hundreds of mammoth bones, dating to approximately 44,000 years ago. Although its exact function remains debated, the discovery suggests that Neanderthals were capable of constructing and organizing their living environments in ways far more complex than previously believed. One of the most remarkable discoveries was announced in 2016 at Brunicle Cave in southern France. About 1,100 feet inside the cave, where there is no natural light at all, scientists discovered nearly 400 broken pieces of stalagmites deliberately arranged into circular formations. To complete it, Neanderthals had to carry light deep into the cave, coordinate multiple individuals, and follow a shared plan. The surprises continued when Mousterian stone tools were discovered on several Mediterranean islands, including Crete and Naxos. Because these islands were never completely connected to the mainland, even when sea levels were at their lowest, some researchers suggest that Neanderthals may have used simple watercraft to cross short stretches of open sea. Even their brains reflected remarkable adaptation. With an average volume of approximately 1,450 to 1,600 cubic centimeter, larger than that of modern humans, the Neanderthal brain contained highly developed regions associated with visual processing and motor control. Neanderthals were capable of planning, selecting materials, organizing living spaces, developing technologies, and perhaps creating structures whose meaning we still do not fully understand. Perhaps the greatest mistake made by modern humans was not underestimating Neanderthal tools, but underestimating Neanderthal intelligence itself. For decades, many scientists believed that inner life was the final boundary, separating Homo sapiens from Neanderthals. One of the most moving discoveries came from Shanidar Cave in Iraq. There, archaeologists found the skeleton of Shanidar I, a Neanderthal who lived approximately 45,000 to 50,000 years ago. He had lost nearly all of his right forearm, suffered a severe injury to one leg, and had impaired vision and hearing. With injuries like these, hunting independently would have been nearly impossible, yet he survived for many more years. A similar case was discovered at La Chapelle-aux-Saints in France. The skeleton of an elderly Neanderthal showed that he had lost nearly all of his teeth many years before his death. This suggests that the community may have prepared soft food for him or cared for him over a long period of time. Discoveries like these do not prove that Neanderthals possessed compassion in the way modern humans understand it, but they do show that their social bonds extended far beyond immediate survival needs. The next question is, how did they treat the dead? This remains a highly debated subject. However, at sites such as Shanidar, Kibara, and La Chapelle-aux-Saints, several skeletons have been found in pits that show signs of deliberate digging. Their ability to communicate is also being re-evaluated. Neanderthals carried a variant of the OXPEC2 gene, which is associated with language processing in modern humans. The hyoid bone discovered at Kibara Cave also had a structure very similar to ours, suggesting that they were capable of producing a wide range of complex sounds. The evidence for symbolic thought is even more surprising. In 2018, a study published in Nature determined that red markings in caves such as La Pasiega, Maltreviso, and Ardales in Spain were more than 64,000 years old. This means they appeared at least 20,000 years before Homo sapiens reached the region. If the dating is accurate, then the creators of those markings were almost certainly Neanderthals. The use of mineral pigments to create signs suggests that they had begun producing symbols that went beyond the needs of survival. Another example is Brunicle Cave in southern France. About 1,100 feet deep in complete darkness, Neanderthals arranged nearly 400 pieces of stalagmites into deliberate circular formations approximately 176,500 years ago. But the fact that multiple people worked together to create a structure that did not directly serve survival needs suggest that they may have possessed social or symbolic activities whose meaning we still do not fully understand. Of course, science always requires caution, and the bone once called the Divja Babe flute remains controversial because many researchers believe the holes in the bone may have been created by hyena bites. And just as we begin to realize that Neanderthals were more like us than ever before, history enters its most dramatic chapter. Another human species began moving into Western Asia and then Europe. That encounter not only changed the fate of the Neanderthals, but also changed the course of our own history. Around 60,000 to 50,000 years ago, groups of Homo sapiens left Africa, crossed the Levant, and moved into Western Asia and Europe. They did not enter an empty land. Before them lay the homeland of the Neanderthals, humans who had lived there for nearly 400,000 years. This was the first time since the two lineages split from a common ancestor, approximately 550,000 to 765,000 years earlier, that two intelligent human species existed in the same region. Constant climate shifts caused their territories to expand and contract, creating repeated periods of contact that lasted for thousands of years. Neanderthals were shorter, with sturdy bodies, broad chests, and well-developed muscles adapted to cold climates. Homo sapiens were taller and more slender, better suited to long-distance migration. But if they stood around a fire at night, the differences between them may not have been as great as we imagine. For many years, it was believed that Homo sapiens quickly replaced Neanderthals because of superior technology. Although it remains impossible to confirm that the two groups directly learned from one another, these discoveries suggest that they at least observed and were influenced by the presence of the other. Of course, this coexistence also involved competition, as both hunted reindeer, wild horses, bison, and mammoths. Both needed safe caves and access to the migration routes of animal herds. When the climate grew colder or food became scarce, conflict was difficult to avoid. But competition does not necessarily mean warfare. In a hunter-gatherer world, simply reaching a reindeer herd a few days earlier could be enough to force the other group to change its plans. The greatest turning point came in 2010, when Svante Pääbo's team at the Max Planck Institute published the first Neanderthal genome. The results surprised the entire scientific community. Most modern humans with ancestry outside Africa carry approximately 1 to 2% Neanderthal DNA. This could only have happened if the two human species had children together. The discovery overturned the belief that Neanderthals and Homo sapiens were completely separate. They did not merely meet, they became part of each other's genetic history. Later studies continued to strengthen this conclusion, as the approximately 40,000-year-old skeleton known as Prehistoric OAC1 from Romania carried 6 to 9% Neanderthal DNA, indicating that this individual had a Neanderthal ancestor only about 4 to 6 generations earlier. At Denisova Cave in Siberia, scientists also discovered the girl known as Deni, whose mother was Neanderthal and whose father was Denisovan. What is especially fascinating is that segments of Neanderthal DNA continue to influence us today. Some gene variants help strengthen immune responses when the ancestors of Homo sapiens entered Eurasian environments, while others are associated with adaptation to cold climates or energy metabolism. But if the two species lived together, exchanged genes, and perhaps even shared knowledge, why did Neanderthals disappear from the fossil record only a few thousand years later? Around 40,000 years ago, the last Neanderthal fossils gradually disappeared from Europe. There are no traces of destroyed cities, no battlefields filled with human bones, and no evidence of a catastrophe like the asteroid impact that once wiped out the dinosaurs. A human species that had survived for nearly 400,000 years and endured many harsh ice age cycles quietly vanished from history. What happened? For decades, the common answer was that Homo sapiens were more intelligent and therefore replaced Neanderthals. But discoveries made over the past several decades suggest that this explanation is far too simple. As a result, most scientists today believe that no single cause led to their disappearance. The first factor was climate. From approximately 50,000 to 40,000 years ago, Europe experienced many extremely rapid changes. Data from Greenland ice cores and marine sediments show that the climate repeatedly shifted between cold and warm conditions within only a few generations. As the environment changed, herds of reindeer, wild horses, bison, and mammoths also changed their migration routes or declined in number. This meant that familiar food sources became increasingly difficult to find. However, climate cannot explain the entire story. Another hypothesis considered by scientists is disease. When the two human species came into contact and had children together, they may also have exchanged viruses and bacteria. However, the most important discovery came from genetics. When all the DNA fragments preserved in modern populations are combined, approximately 20% of the Neanderthal genome still survives scattered across modern humans. This shows that part of the Neanderthal population never truly disappeared. Over many generations of interbreeding, they gradually became integrated into Homo sapiens communities. For this reason, a growing number of researchers believe that the disappearance of Neanderthals was not an extermination, but a prolonged process. There was no single cause. Instead, multiple factors acted together over thousands of years. In 2010, a research team led by Svante Pääbo at the Max Planck Institute for Evolutionary Anthropology published the first Neanderthal genome sequence. The results completely changed the way we understand human history. Neanderthals did not disappear entirely. They still survive as a part of us. The influence of Neanderthals can also be seen in many other traits. Some gene variants associated with keratin may have influenced the structure of skin, hair, and nails, helping the body adapt more effectively to cold and dry climates. Perhaps the greatest value of these discoveries is not only that they help us understand Neanderthals, but also that they help us understand ourselves more clearly. Looking back across their entire journey, perhaps the question, have Neanderthals disappeared, is no longer as important as another question. How different are we from them, really? The story of the Neanderthals, therefore, did not end in the caves of the Ice Age, but continues quietly within the story of humanity today. The story of the Neanderthals is not one of failure, but of a resilient human species that once mastered the Earth. Archaeological and genetic evidence confirms that they possessed intelligence, sophisticated technology, and rich social lives. To understand the Neanderthals, therefore, is to better understand our own place in the ongoing story of life. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.